So hello everyone, welcome to the ethics seminar series, and I'm John, the seminar coordinator. So I'll be moderating this seminar with our communication specialist, Kazi. And this is the first of our seminar series in the fall and the first in-person ones. So before we get started, just so you know that we have a wonderful schedule in the fall, so you can check out our schedule on our website. And you can find the time, whether it's in person or not, and details online. And also for this seminar, before we get started, we will have our sponsors who invited a speaker, and then afterwards, we'll have our associate director Ralph to give a few opening remarks. So Ralph, please go ahead.
Yeah, just real quick, just welcome everybody. We've got, as John mentioned, we've got a great seminar series lined up. John and Kazi do a great job. So Rebekah's going to do the talk here. I'm a big baseball fan. We have a great leadoff hitter. So that's Rebekah here today to lead off this series. Just a side note too, I was just telling Kazi, we, Ellen and I and Andy were discussing, had a conversation with one of the lab chiefs at Goddard, who we talk to routinely, and he just mentioned he thought this was one of the best seminar series around. So he gave a lot of praise. So look forward to some good talks and turn it over to Shishao. He can introduce the speaker.
Yeah, thank you. Actually, it's our great honor to invite Dr. Rebekah Esmaili to come here. Actually, she's our long-term friend. Actually, I sit the cubicle next to her when we were in the M Square building. And Dr. Rebekah is a senior research scientist at the Science and Technology Corp and the JPSS Proving Ground Risk Reduction Program contractor. She focused on the transition research idea to real-time operation for JPSS. Actually, one highlight is in 2021, she wrote a book called Earth Observation using Python, a practical programming guide, which has been published in AGU. Actually, it's also available on Amazon. Actually, just look at it.
It's free in the library too.
Yeah, it's a free in our library, so it's a benefits for our UMD community. Rebekah received her PhD in atmospheric science from University of Maryland in 2016, and her bachelor in science in physics actually from James Madison University. Also, I want to say like this is a very timely seminar because at NOAA there's an initiative to transfer our operation to cloud. And in cloud, actually, a lot of coding, like IDL code, needs to be adapted to Python. And if with this kind of tool, it will make our operation and work a lot easier. And lastly, I just want to say this seminar is jointly sponsored by North Star. Actually, she was initially invited by Dr. Chen Yang Chao from North Star, and I found like this a very interesting topic. And as like the lead from the ASIC Satellite Carrier Affinity Group, we also want to sponsor this seminar. So I think enjoy the pizza you have. Thank you all.
So thank you all so much. It's really exciting. This is kind of my first like super live seminar in a long time. So it's really lovely to see everyone. And for those of you who are online, thank you for joining virtually. Sorry, don't get any pizza though. So I just out of curiosity and people in the chat too, you can type your answer, but how many of you of the three words in here, ChatGPT, IDL, and Python, which of these you're most excited about? ChatGPT, raise your hand. Okay. All right. IDL. Python. Higher, so I can see. Actually, so most of you are excited about the ChatGPT part, but Python was second and IDL was third. So online community may have different answers, but Kazi can do a summary for science purposes. Okay.
Split between ChatGPT and Python.
Oh, okay, so it's kind of similar to here. Here, I hear some noise. Is that you? Okay, so just a little bit about, I wasn't sure if we'd have some students in here today, but basically a lot of the code that's written in earth sciences is written in what I call, I'm kind of labeling legacy languages such as Fortran, C++, and IDL. And I'm going to talk about IDL today. I don't have as many bones to pick with Fortran or C++, but the IDL has a lot of really cool features that made it very popular for scientists. One, when you're coding an IDL, it is pretty similar to Fortran, so it wasn't very hard to switch between the two languages. IDL had was pretty fast too, so it's like I consider it a pseudo compiled language. It's most of the functions are written in C, so operationally from a computing standpoint, it's really fast. But it also has advanced graphics capabilities. There's some pictures here on the right. And as I've learned actually from Chris Barnett, who's in the room, that in the days of yore, you could make plots in Fortran, but it looked extremely painful. So thank you for that life lesson, Chris. So it is possible to make graphics in Fortran, but you probably don't want to because you have much better choices these days. However, some cons of IDL, we could keep using IDL forever, but IDL is quite expensive. The licensing costs I find are prohibitive for individuals. Most of the time you get licenses bought by a large organization, but not all of them have it. And so the continuing maintenance of the code, it gets pretty expensive. And I think that's one of the driving factors for some of the code conversion that we're seeing taking place at NOAA and probably just around in the industry in general. Also, I think I don't have it on here, but for cloud computing purposes, I've personally found IDL is not friendly to cloud computing. Especially as we're kind of moving more to serverless technologies that are oftentimes like very friendly to Python and Python functions, but not so much for IDL. That may change. IDL is a company, they evolve, they may start making features. I know from an AI standpoint, they have developed features for AI capabilities and stuff, but it's not quite there yet for cloud computing. And they have add-on libraries that make that are friendly towards sciences, but Python just has a huge community of contributors. So there's just a lot of libraries that can save you time when you're coding. And these legacy languages are also challenging to maintain because we don't teach classes in IDL or Fortran. C++ is still around, but it can be hard, as I've had to hire folks, and it can be really hard to find people with that skill set. So it's as time moves forward, it's challenging to continue to maintain the code, both from a workforce standpoint and a licensing standpoint. So not saying IDL is bad, but there's some problems with it moving forward. So why Python? We could convert it to infinite other languages. One, Python is open source and free, so you don't have to worry about that licensing cost. The syntax is pretty simple. It's not similar to IDL too much. There's some things that are similar, but it's a pretty simple language to learn compared to some more complex scripting languages. And it is designed for scientific computing. And there's, like I was saying, a strong community with lots of example code online, lots of tutorials. There's just resources everywhere to learn it. And you can see here from this top programming languages, Python is number one. It depends on how you cut it. But even though C and C++ are actually still on the list, Fortran is so far down the list I couldn't print it, and IDL wasn't on it at all. So from getting for the next generation workforce standpoint, it's a good choice. So this might be a bit of an eye chart. I tried to make it's hard to display code in a nice way, but let's talk about some of the syntax differences. So in Python, when you define a function, you would say def real distance. I'm going to walk through this function a little later, and this is actually one Cheng Yang provided to me. So some of this code I'm showing today is actually modified real code. Whereas in IDL, you would type function and then you would construct the arguments with commas and no parentheses. So that's a minor difference. It might be annoying to type that up, but things like comments, it's using a hashtag or a pound sign, as it used to be called, to define comments in Python, whereas in IDL you use parentheses. And also a lot of times they would end lines with parentheses to kind of signal to the program, hey, this line is done, next line. And yes, so that's one syntax difference, and this is not going to be a full list of everything. But indentation has meaning in Python. It's not just to make the code easier to read. it actually is signaling that this code here is part of this function. Or if you have an if statement or a loop, the indentation has significance. And if you get your indentations wrong, your code can go very, very horribly. So you have to be careful about the indentation. Whereas in IDL, the indentation is kind of an optional thing. It's just to make the code more friendly for someone else to read. I have been handed code with no indentations in it, and it is not fun. So that's just like another difference in, so in IDL, like they would have function and you have to have end statements to say this code is done for this section. Whereas in Python, when you just indent back to the left, that's no longer part of the function. Just little small stuff here. I already talked about the def function differences. And this one can be tricky. Probably for the general programmer, wouldn't really care so much, but for scientific computing, we care a lot about the typing. So Python default is float is 64, and IDL it's float 32. So if you want a double precision number, you actually have to specify that you want it in double. So little things like that can trip up, I think, folks who are in the scientific community. And lastly, IDL has a lot more native functions, whereas in Python, you'll have to import things to do like sine and cosine, more quote unquote advanced mathematical functions beyond, subtraction, addition, multiplication, exponents. Those are base Python, but then if you want to do like trigonometry or anything else, you do have to import another package. Base Python comes with the math package, but NumPy I would be the one I would recommend to use to process those functions. Okay, so that's just a typical syntax thing. I think over time you would get a sense of, if you're doing a code conversion, how to some of the nuanced differences. But there's some tricks, because IDL and Python are both designed to handle big data. A lot of people are processing very massive data sets using Python. But because Python is an interpreted language, when you compare to Fortran and even IDL, it's there's an overhead to using it, so it does slow down the code. So to really optimize the code, I recommend using the built-in functions, which are all written in C, and or packages like NumPy, which is designed to handle like matrices and arrays. And these are highly optimized, and there's a lot of like even corporate money behind keeping Python NumPy very efficient. So I highly recommend using those versus using some package you found from some really smart person on the internet, but it's not like, it doesn't have a huge team behind it. So let's see. So then there's also some support packages called Cython and Numba that can speed up your code. If you need to use loops, I can't get away from using a loop in Python. I would use Cython. Basically, you write the code and it's converted into C, compiled, and then you run the compiled code in. So if you have a function that's pretty simple and it doesn't use a lot of external Python libraries, and it's using mostly the base functions or NumPy functions, you can write it in Cython and compile it and run it. And loops are really, really slow in Python. So here's an example. If you were gonna, if you wanted to take the sum of a number that's squared, and you loop it for numbers, and say you pass a list of 10 numbers and it computes it 10 times, that's going to be a lot slower. And these times are based on what my computer was. If you run the same code on your computer, it may be different. But whereas if you use NumPy, which is optimized, you can use the np sum command and np square the list of numbers. And then that will process way faster than if you just run this loop, which would probably not be a problem in IDL. So just little tricks like that you want to use. And in appending functions, because you don't have to, unlike Fortran, you don't have to define variables at the top with their array sizes. IDL didn't require that either, but if you have to constantly append to the same array and you didn't predefine the size in advance, that will cause slowdown. And it won't cause slowdown right away. What happens, it'll cause an exponential slowdown. So you might be looking at your code like, okay, and you get up and get a cup of coffee and you come back and it's like suddenly just crawled to a halt. It's because it's running out of memory. So you should try to pre-allocate, or if you're going to do iterative appends, use a list. It's a little better. And so there's some tips also in this article as well. Some of these I came up with in my personal experience, but they had a few additional ones as well. One trick too is that if you call functions in Python, there's a overhead to calling functions. So it's actually faster to pass a list inside a function and process it rather than to run the function over every element of the list. So this, again, is really hard to see. Hopefully the online people see it better. But in example one, you're passing a, you're calling the function 100,000 times, and in this part here too, it's a similar function, but you're passing in an array, or it's actually a list, and 100,000 element list into the same function. And the is I have 0.58 seconds for the first option and 0.37 seconds for second option. It's not a huge speed up, but if you have a lot of functions and a lot of data, it adds up. Other things to keep your code thinned out a little bit is you can import an entire package into Python. If optimization is key, only import the parts or the functions in that package that you need. That will that'll avoid bulk. And some libraries, especially ones that are not like NumPy and heavily supported, may have a lot of the bulky. They have like a ton of dependencies. Just be aware. I know there's some that, like, if I try to install it in my environment, they take forever to install because they have like 1,000 dependencies. Avoid those if you really need optimized code. And also Python by default only uses one core. So if you need to do multiprocessing, you do have to manually tell it to do that. But there's a multiprocessing library that can help with those things. So you can dust off your MPI knowledge or your parallel computing knowledge that you have. Okay, quiz time. So people online can respond in the chat, and Kazi can check. So why should we convert IDL to Python? Is it because it's faster? Is it because it automatically documents the code more accurate, or is it for maintenance, reducing maintenance cost of code? A, raise your hand. B, C, D. Yay, it was D. Good job. There's no prizes and there are no grades. So let's talk about ChatGPT. So the third thing, and what everyone said they were most excited about in this talk. So ChatGPT is a generative pre-trained transformer. That's what the GPT stands for. And in terms of the lineage of where that came from, and this is not my area of AI expertise, so don't ask me too many questions about this. I'll just start telling you to ask ChatGPT. But you know, if you essentially have a lot, like initially you have a bag of words, and I got this from Wikipedia, I thought it was pretty funny, but you have like a lot of words, and then over time you use RNN or LSTM models, and then you use fancier LSTM models, and then attention-based models, and then that's where transformers sit. So it's like it's like a really long evolution of AI models here. And so it uses a large language model. It basically has scraped the web from 2000 to up to 2021, including like Stack Overflow. They scraped a lot of code. They scraped Wikipedia, and that's where its pool of data comes from. The innovative part about it too is that it has a chat interface, so you can pose your questions in a way that's very natural. It's kind of like how I think of questions in my head almost. And then I just can type them into the prompt, and then it searches that massive amount of data that it has to come up with an answer that is oftentimes tailored more so than if you had just gone to Google search and had to do Stack Overflow. So this is one lesson if you're a student. There's a lot of Googling in this job. Like, it's okay. Like, even I have friends who work at Google and they Google, so it's fine. You can't remember everything all the time. So there's the GPT 3.5. That's the free one. If you have a paid account, you can use GPT-4. It's better, but you only get like 100 as of right now, only 100 prompts before they cut you off and say you have to use GPT 3.5. And ChatGPT is cool and it's fun, but it also makes us more productive at work because it can speed up some of these code conversion, some of these issues that I brought up before. It can help with them, but just I'll spoil the ending is that it can't do everything. You still have to use your brain. We're going to still have jobs. Don't worry for now. So yeah, so some of the things it's really useful for is some of these automatic syntax conversions that I used to have to control find to do. So like for instance, in IDL, they use the parentheses to hold for their functions and indexing. Actually, they use the parentheses for indexing, actually, and functions. And whereas Python uses square brackets for indices. So if you had some IDL code in the days of yore, you'd have to control find and convert everything and probably mess something up at some point. But if you drop the code into ChatGPT, which I'm showing an example of, then it will do that for you. So that saves you some time. And that's also a very painful task that maybe people enjoy it. I do not. Oftentimes if there's some piece of code that I'm interested in writing, I might, if it's a little more complex, I might go online and see if someone else has written something similar. But it can provide a customized example for that type of code that you're looking for. And it's super easy to use. I almost feel like embarrassed showing how to use it because you literally just type a few words in and you can drop your code and then hit enter and it will populate the screen with the code. So I'll let it kind of finish what it's doing just to show. Yeah, so I just dropped some IDL code in there and out pops the Python code. And I showed that in the previous example. Okay, so let's do the live demo. I love doing live demos, but it's always a little bit dangerous. For those of you who are in here, I don't see any laptops, so y'all are probably just gonna watch me do this. But if you're online and you want to do the demo too or play with the code, I do have my GitHub page has an example. And so we're gonna do a quick live demo of how to some IDL code that's using the Haversine formula. Well, let's convert it. Let's see how it goes. Oops. All right, so if you are following along online, you click on Launch Binder in the it's at the bottom of the GitHub account, the GitHub page that I linked there. So I have to give it a minute. I should have launched this right before the talk. Oh, it's pretty fast today. Sometimes it doesn't behave. All right, so if you are using it, this is just a quick example here that I made, and you can work through this notebook if you want. So I'm going to run these packages that we need. So here's the idea. Let's not do that one. Let's do this other one. So here's the Haversine formula, and I got this from Changyang. So thank you to them. So you can copy the code, and this is IDL. Where's copy? It's underneath this thing. Can I move this? Okay. Copy cell. And then you go to ChatGPT and you can say, and it's really important to have the prompt, prime the prompt, as they say. So this is a kind of a simple exercise, but in a lot of times you want to write, I am converting IDL code to Python. Can you help me? And you can even add things like, I really want the code to be efficient, or I want it to use the NumPy function. Actually, I'll show that example too. So literally gonna paste the code. Let's see, paste. Nope. I did. Let's see, let's try again. I don't want to copy them, so. I love showing I can't do copy paste in front of a live audience. It's also at an angle for those of you who aren't in the room. Yeah, this might do it. There we go. Woohoo! So and there out pops the code. And if I were to take this code, and you can go up here and copy the code. I can, I'm going to add a cell where the cell's already here and just run this. And did they give me some examples? Sometimes they do that. But we can actually just test it out. So let's see, it goes lat-lon. So let's say negative 35, 100, oh, not negative 35, let's see, 35, 100, and 45, 130, negative 130. And I know this might be hard to see. I should have made this a little bigger. And out pops a distance in kilometers. So I put 0 effort into this. So that was helpful, right? If you had to do this by scratch, that probably would have, I mean, it's not that hard. It probably would have taken like 15 minutes. So, hey, I'll take it. I'm busy. So if you're not busy, you don't have to use ChatGPT. So let's go back to our PowerPoint. So it was that easy. And if you want to work through more examples, I do have some additional examples online. Okay, so just some best practices in consideration is make sure the code you're using works. This is true of any code conversion. It's really important to have a functional code with like inputs and then an expected output. And then when you run it in Python, then you make sure that the outputs match. It's really critical. Otherwise, the code might look good. It might even run, but then the output is completely different and something went wrong. And ChatGPT, they call it hallucination, but it's kind of has an authoritative tone. It's friendly, but it acts like it knows everything. So it will literally give you bad information and pretend it's giving you correct information. And that tripped up some lawyers in they should know better. But some lawyers like literally copy pasted stuff they found ChatGPT, and I found ChatGPT gives completely fake citations. Like you ask, hey, give me a DOI for this, and you'll go to it and it's non-existent, or it's like a medical journal. They call that hallucinating, but it acts like it knows. But these lawyers just copy pasted it and put legal cases that didn't exist, and they got caught, and now they're in trouble. So ethics, people, ethics. And so, yeah, don't blindly use ChatGPT. I showed an example where it's pretty easy and it worked. And ideally, I would open IDL and make sure those numbers matched. But there's some examples I have in the rest of that notebook there where it fails. And you do have to go back and put on your thinking cap and figure out why. So you don't need to be an expert in Python or an expert in IDL, but you should have an understanding of both languages. And I do think it's for us as scientists, speed benchmarking is going to come into play because we do work with very, very large data sets. So using the time function and just checking how fast things are running. I don't think the first step should be optimizing. The first step is just get the code working, and then you can go back and refactor and make it better as needed. Let's see, quiz time. So what is a key consideration regarding privacy when using ChatGPT? ChatGPT doesn't collect any data. Raise your hand. A. ChatGPT only uses personal data for training. Raise your hand if you think it's B. ChatGPT's interactions may be logged and analyzed. C. And D. ChatGPT encrypts all user conversations in real time. Okay, it was C, and that's what people raise their hands in the room for. So do not put any proprietary code into ChatGPT. If it's something that you would not post on GitHub, do not put it in there. Okay, so that's your fair warning. So just be careful what you post in there. You may want to talk to your boss or your PI and make sure they're cool with it before you start dumping proprietary code in anything. I mean, some things you can do is you can sanitize it and like remove any type of, like maybe take small chunks of it, like little functions and stuff, but not like whole code bases and things like that might be okay. But again, work with your boss. And there's some advanced ChatGPT features. So like I was saying, you want to prime the prompt, and this is true of coding, or even if you're using it to help with other tasks, is that you want to give it a lot of information up front about what you're doing. You'll get better responses. Like I like to use NumPy over the math function, so I may tell it in the answers, use NumPy where appropriate, and it'll change the output for that. And you can also provide, like if there's constant instructions you have to apply to all your chats, you can actually add that. Then bottom left, they have a way to update it, so you can just say, like for instance, I'm a research scientist often converting IDL and Fortran code to Python, and then you can ChatGPT second prompt will ask you how do you want to alter all of your responses in all of your chats a certain way. So if you find yourself having to write the same prompt, prime the prompt over and over and over again, you can use this feature to apply it to all future chats. It's not going to go back and rewrite your chats. because you can save them. When you make an account, you can save your conversations and use them kind of as a reference to go back to. Okay, and this is my personal opinion. Okay, so should we convert all IDL code to Python? No. I don't think it's necessarily cost effective. It takes time to convert code, even if you have ChatGPT. And you still have to retrain your colleagues and stuff to do the code conversion or to work with Python. So work with your management, your PIs to decide what should and shouldn't be converted. I think things like, again, these are my opinions. I think things like analysis software and visualization, data readers and converters, go ahead and convert it to Python. It's free. It's easy, much easier to share code. The kind of code you would maybe want to put on GitHub, whether or not you're putting things on GitHub, things you might share with colleagues. And it's cloud and anything on cloud computing. I didn't add that to the list, but Python is just far superior to work with when using cloud technologies. But things like retrieval code and complex gridding code, you may want to keep that in a compiled language. So if you have an IDL code, maybe you want to just convert it to Fortran instead, and then you can call it in Python. You may be able to rewrite it. I don't know, but chances are it's going to be a very, very messy process. It could introduce bugs. It would be very expensive to do. So maybe in those cases, keep the code in the native language and then write Python wrappers to run the code. And code that you don't use that often, not worth the time. It may not even be worth it, even if the code is short. You just may not need it enough. And if you're using AI and machine learning, I think I've heard IDL is starting to have AI capabilities, but I think the Python capabilities are just extraordinary. So if you want to get into AI, Python is the way to go. So I'm going to show I'm going to keep going with the demo, but maybe useful to convert. It's maybe strategic to convert legacy code from languages like IDL to Python. Python's free. IDL costs money, and it's very cloud. It's cloud native almost. Python is an interpreted language, so one of the challenges is getting the code to perhaps run at the same speed your IDL code is running in. So you'll have to spend more time refactoring the code. ChatGPT can really help with initial code conversion. But then ChatGPT will give you incorrect responses sometimes. So, or things, it'll think it's right, but then you'll have to go back in and work on indexing and that sort of thing. Just the last reminder, only enter public code in there. I recommend cutting large programs. We tend to write large programs as scientists, cut them up into little incremental parts. The side effect is you do accidentally modularize your code. So that's great. And just understand some of the ways ChatGPT can fail, and that way you can look out for it. So for those of you, so it's like 12:34, so I'm going a little ahead of schedule, but I do have this interactive example. So if you want to try converting a few additional IDL functions here, you can do that. And I showed you can go to the binder link and play through these. So it kind of gives you a fun little environment to try some of this out. So I think that's the end of the PowerPoint. I'm going to I'll go through a little bit of the live demo. Some more. Let's see. Where is it? There it is. So we're still in this. So this is, so I'll walk through some of the code here. Why does it come back? It's haunted. So this is a program that will when you finish writing it, you'll be able to give it a point. And I have a couple of VO's day-night band swaths in here in this data directory. You shouldn't usually upload big files into GitHub, but don't tell GitHub. They're not that big. And you have a VO swath here, and you'll be able to pass in a point, and it'll be able to find the radiance at that point and the surrounding pixels. So what we can kind of break this down. 1, we have to import the data, and 2, we have to write a function to search, and then 3, we have to write kind of a function to drive all of these processes together. So the packages we'll use, and let me make this bigger. The packages we'll use are H5Py. I also really am a big fan of X-Array. Let's not go away. Okay. I'm a big fan of X-Array, but H5Py just handles HDF5 files a lot better. in my opinion, and NumPy and the time function so we can benchmark a few things. So the first thing we'll do is import our data. So I'm going to show how I'm going to use ChatGPT. So these are, I think all of us worked with HDF files? Raise your hand. Okay, good. Okay, so I don't have to explain too much about, and I learned my lesson. I'm not working on my main computer, so I'm kind of. Okay, so now I already primed ChatGPT, so I don't need to say, oh, convert this code to IDL, because if I'm in the same chat, it remembers my earlier prompt. So I'm going to be extra lazy and just pop the code in without any further explanation. And ChatGPT is a good friend and smart and figured out what I'm trying to do. So you can just copy the code, make the meeting controls go away. I'll keep doing that. Okay. Paste. Technically, I already imported H5Py, so I don't really need that, but thank you for suggesting that, ChatGPT. And so I didn't, oops, I didn't import my packages. There it goes. So if you want to double check that stuff imported properly, there's a couple of different ways you can do it, but let's just print out the longitude values. Okay, they look same. These look like real longitude values. So I'm going to get rid of that. And then so the target point we're going to look at is this one. I'm going to tell you in advance that one is within the granule that we downloaded. You saw from the plot I made. So that's why we're picking that point here. So I just ran that line of code. So we already computed this, I already copied this real distance function in earlier in the first demo. Well, one thing I didn't do is it's using the math function. I was explaining earlier, NumPy is I would say a better choice. So ChatGPT gave a perfectly fine, perfectly reasonable solution, but I know that just because we are experienced scientists that actually it's better to use NumPy. So I could just recopy this code, this IDL code. And then let's go back to ChatGPT and I can say, can you convert the following code to Python using NumPy? Pop the code in. Give it a minute. There's my prompt. And so now instead of using the math package, it's using NumPy. And so you'll see instead of math, you'll see NP. So we can, so it did that for me. That was nice. I mean, I could have copy pasted NP everywhere or kind of had to check what the commands were in NumPy to make sure it was the same. But hey, ChatGPT saved me a little more time. And that little bit of time will add up. So this is my old function. I'm going to replace it with what I just asked. So now instead of math, it's using NumPy. So I got to rerun this code block. And so here's my test. Let's see if the numbers are the same. So I have 2769. It is still 2769. So that change worked. It seems reasonable based on the long coordinates I provided. Okay, so I basically am running another test here. So this is another set of coordinates, and here's a distance. Okay, so that part pretty easy. In quotes, pretty easy for me, at least. You know, if you're learning, I understand it might be a little more challenging. But so here's a longer program. So this program takes the data we imported, that function that will search, and you can pass in the latitude longitude coordinates from this day-night band, and it will search them all and pick the point that's closest. So it's not that long, but it's a little longer than what we've seen so far. So I decided to break this up into part 1, part 2. So I suggest so you could either take this code and dump it all into ChatGPT, it would handle it, but I think it's strategic to just kind of break it down. You have to study the code a little bit, understand what it's doing, and just pass in like in parts. So this part here, we could just apply the real distance and pass in the coordinate in the array. It can certainly handle that. But it's slower to pass all of the lat long coordinates in there. It's actually faster if we just maybe focus on the ones we know are really close to the point. So we can only grab the points that are within 1 degree of the so the target lat's the like the point we're giving it, and the lat veers is the array of points. So we can pass in just we can filter out everything that's further than 1 degree away. So that's what this part here is doing. And so, you could write this yourself, or you can just have ChatGPT do it. Unfortunately, now I can just assume it's going to use NumPy functions. And there it goes. And I won't do the whole example. I want you all to have some time to do it yourself, probably a few more minutes of this. So I'm going to go down here, and why is that? So I'm just going to copy the part 1 here. And so that part will work with no issues. It doesn't output anything because I didn't ask it to print, but if we wanted to print like some numbers to make sure everything, whoop, just want the variable. Okay, so, oh, that's empty. That's not good. Oh, because it provided, I don't want that target lat long. So what ChatGPT did is it was very nice and provided a target lat long, but I already have a target lat long, and that one is not in the not in this swath. So let me go back up here, rerun my target lat long. So it was the correct answer, but I want this target lat long. It was trying to be helpful, but it wasn't. So this one should yield some numbers here. Okay, so what this one did is it says, take that 2D array, find the things that are closest to that point, cut everything else away. Then you're only passing a much smaller list of distances, of points to check the distances in that real distance function we wrote. And this further refines the data because of these, we only want the points that are even 1 kilometer away. And so at the end, these are the indices that are left. So remember I was talking about benchmarking. So maybe we want to compare how it would be to pass the whole array in versus that smaller, just around that point array. And that's going to be faster because we're doing way fewer computations. And so the first one where we passed the full day-night band lat long geolocation points in, it took about, for this computer, or not this computer, on the cloud, it took about 0.17 seconds. Not that slow, but it was 0.049 seconds to run it with the smaller subset. So it'll add up. If you're doing a full global day, that could actually take a lot more time when you think about that. Okay, so this is where things are going to get messy. So we're going to look at part 2. And I'm not, like I said, I'm not going to go through everything, but see part 1, part 2. Things get kind of messy here. So we've got a lot of indexing going on. We've got some if statements. So I'm going to copy that. And it's not that ChatGPT is wrong. It just gives an answer that looks good, but it doesn't actually work the way it doesn't understand the code enough. So, and I'll walk through what's kind of wrong with it. So you look at it like, okay, this looks valid. A couple of things happen here is there's this index, which we had in the original IDL code, but this index is it's not going to behave the way we expect. Let's see, benchmarking and where did it go? Okay, so it returned a point, but this point, I told it to pass points back that were within 1 degree and 1 kilometer, and I know it's hard to read, but this is the distance. So this distance is 1,857 kilometers away. That's not right. Right? It should be within 1 kilometer. It should be 0 because that point is, you saw it, that point is in that array. So something went wrong. ChatGPT isn't perfect. So maybe I'll just leave it there. I do have the answer online. So if you want to get to the bottom of this very exciting mystery of why this didn't work, go ahead and try out the example. So I think I'll close up shop now because it's 12:46. And if you're working through the example and have any troubles, just email me. But thank you all so much. It was really exciting. I'm really glad I could be here and have a good semester. So are there any questions?
So we have a ton of questions
Oh, good.
online. But obviously we want to let people give in-person questions too. So John and I are going to tag team this. So maybe we go back and forth.
Thanks for the talk. I just want to know a little bit more about what behind the ChatGPT when you transfer the code. In your first example, if you ask the ChatGPT, let it to help to create a code to calculate the distance from that long, and would be the code generated. I think it can generate a code first place. And if the code it generated be the same when you give it a reference IDL code?
Yeah, so if I didn't have that distance calculator was Haversine, it's common knowledge, it's commonly used, it probably would tell me use the Haversine formula and come up with some code. And it probably would be the same. So I just happen to have IDL code, and because I was trying to show the IDL to Python example, but let's say you had no code, it would be able to come up with common formulas like that.
I just want to know how smart the ChatGPT is. Is it mimic the human mind? Because I personally transfer the code from like Fortran to Python, and I know from the human mind, I know I will have to have the knowledge of Python, the grammar and the knowledge of the Fortran and some experience, and know the difference between these two code, so that I can also do the copy, but I do a lot of changes to feed for the program, feed for the grammar of Python, and some difference. The Python is object oriented, but the Fortran not. So I just want to know, the ChatGPT is doing the work in the same way, or it has some engine behind it, the building engine behind it, just automatically directly transfer the IDL code to the different language to Python
Yeah,
code.
I think it's pretty literal, the way it's doing it. I don't know how the guts of it work, I'm going to be honest, but from my experience using it, I find it does kind of a literal word for word, but it has context too. So it's not just, I remember early Google Translate was really bad. It got a lot better, but early on it would just find the literal matching word in English and in Spanish and just do an exact translation. You'd read the end and you're like, sort of makes sense, but it sort of doesn't. It's better than that. It has the context of the whole program, and I found it even will comment the code for me sometimes because it sees what the program's doing, but it does make a lot of mistakes. And I do spend a lot of time going back with more complex code, going back and finding either a better Python package than the one they suggested, or taking out loops. Loops are very common in Fortran. I find the loops are where I spend a lot of time redoing it. So I consider it a first guess. It makes a good first guess as to what the code should look like. And I'd say runs about 50% of the time. And then 80% of the time it will run with like one or two little changes. But then getting the code to a state that where I actually want it, that takes a few hours, I would say, of me going in and thinking about the code a little bit more. But if I did that from scratch, it probably would take me all day. So that's how I use it.
Thanks.
Okay, we can take an online question. So when adding code directly to ChatGPT, does ChatGPT now own the code to reproduce elsewhere, let's say as a response to someone else's question?
Yes.
Okay, easy. Next question.
Yeah,
John.
So I've used ChatGPT a bit, and I took your course, and so I was asking questions about HCF5 files and Python, and Fortran, since that's all I ever programmed in. And what I found is that it's very convincing and I think good at giving narrative responses to general questions. Like how do I read HDF5 files using Fortran, which I asked a whole lot of people and I didn't get very satisfying answers. So I got a very satisfying answer from ChatGPT. I haven't tried it, or I showed it to Ralph, so he knows that it's very convincing and so on.
Did it look legit, Ralph? You think so? Okay.
Yeah, I mean, I don't think Ralph knows any more than I do whether it'll actually work. So at some point, I'm hoping I'll have time to sit down and actually, code it and see if it works.
Yeah, I mean, it's kind of nice about Python is it is interpreted. So it's a lot faster to test the code in Python. If you're checking things in Fortran, you have to write a whole program and then compile it and run it. So I think that's why languages like IDL were so popular, is like you didn't have to do all that overhead of just running 2 lines of code. So.
Okay, another online question. This is perhaps not a question for you, but maybe you know the answer. Does NOAA or STAR plan to invest in the enterprise version of ChatGPT due to proprietary or privacy concerns? So,
Do you want to answer that, Cheng Yang?
Actually, the government is developing a policy on the use of AI in general, especially the generative AI, which GPT belongs to. So the policy actually at this point, there is a draft guideline. So the government is very cautious. For example, at this point, you cannot use NOAA email to register ChatGPT. And so you certainly cannot have a NOAA account on ChatGPT because the generative AI can be very useful, but it can also be very confusing and it can lead to a number of problems. But use your private account, there's no problem. And I have used it many times. Like Tiger mentioned, can you ask ChatGPT to write a code? And I actually did. I took some measurements using spectrometer. I described the text files in there are 2 columns, and I make a plot, and I described it, and I actually did it, and I ran it, and it works. So that in a sense is kind of smart, right? Yeah, it's not just to repeat some other people's work. It's actually generating something based on some thinking, some knowledge, and
another in-person question, Mike.
You might not have been around long enough for this, but have you tried it with Python version 2 to 3?
Ooh, no. I hope to not see too much more Python 2.7 code.
A lot of it.
Oh no, you can give the seminar.
Any comparison study that you are aware of between ChatGPT and Google Bard in terms of who gives better response in code conversions?
No, but we're at a tipping point. All of these tech companies are going to be, you're going to just see a million of these things pop out. I think even like Snapchat has one. I don't know why, but it does. Yeah, well, this is a tipping point for this technology. And I also kind of was thinking this morning, I don't know if I were to give this talk 1 year from now, if it'll even resemble what I'm doing today. So things are changing really fast. But there's also GitHub Copilot. I hear good things about. I haven't used it yet, but I think that one's also pretty good.
Thank you. In person.
So you use the 3.5 as the demonstration. Have you tried the 4.0, the latest version? And is it really worthwhile to pay for that version?
Admittedly, I pay for it, but I didn't show it today because it's I didn't expect people to go online and pay for things. But it is better. It's just that it will produce output a lot slower, and and you have a limit of about 100 prompts. And I if I'm busy with a project, I'll use 100 prompts really fast. So I don't use it as much. But the results were a bit better, especially the text results. But for coding, I didn't check it quite as much, but the text looked better. I mean, I think the main reason to pay is that you pretty much have 100% uptime access, whereas like when I was on the free account, it would go down and you couldn't use it. So I'm also just an early adopter of technology. I bought all those Amazon Echo things, so I have it in my nature to do it.
IDL sets plotting environment variables separate from plotting functions. Does ChatGPT handle this?
Plotting environment variables separate from functions?
Yes. Maybe.
I mean, it understands the IDL syntax. I think there's enough IDL content. So I think anything you do in IDL, it should be able to handle the conversion. Yeah, I'm going to say yes, but maybe it's more of a maybe. I have to check.
In person? I think I have a couple more online, so I can always just take over.
Yeah, actually, the other day I was using ChatGPT and I was talking to it like a couple hours. Do you think in the future we will be more isolated, just devoted with ChatGPT?
Like a companion.
Yes.
Yeah, maybe. It's very polite too when you
Yes,
talk
yes,
to
like
it.
you can ask anything, and also like it will surprise me all the time.
I mean, I was joking before about getting all the those Amazon Echo devices, and it's like I think ChatGPT is basically what I was hopeful that those devices would be. But it's much more sophisticated. Those devices came out 5 years too early, I think. And they've kind of canceled the budgets for the development, so I don't think they're going to get any better. I would say it's like so the question is, how do we compare the output from ChatGPT to like a software engineer? I would say it's a junior developer level, because it is able to do basic coding and you can give it instructions, it can do it. But when it comes to more advanced things, like you said, you have to go back and refine the code. So, to bring that code to a mid-level or senior level code, you have to, we still have jobs for now.
Do we have any idea how well ChatGPT could be used for other languages, like converting IDL to Fortran instead of Python?
I think Fortran's pretty, I mean, I would say IDL is harder to find code examples for than Fortran. So it should be fine. I haven't done extensive IDL to Fortran conversion, but I'm pretty sure it can handle it. The syntax is really similar.
So a slight tangent, okay, but one of the things that I fear, and I would love to be reassured with ChatGPT, is that there's an entire layer of the development. I mean, I'm talking about human development process. In other words, you have students, they learn their field, and then they start to apply it. And usually those people are, entry-level support scientists, sometimes they're postdocs, and it won't, with ChatGPT, I'm pretty confident it won't be long before a lot of the ways I used postdocs, I'll just use ChatGPT. I mean, that's, I think that's inevitable. And this is true in every field. It's not science specific. Any field that has a sort of a knowledge base that people accumulate as they start. Think of the apprentice level. Okay, apprentice level, I think, is going to go away. So will we be okay?
Yes. There's always been, I feel like there's just always been, I mean, probably when IDL came out, people were like, oh no, Fortran, like look how easy IDL is compared to Fortran. We're going to lose those skills, or I don't need as many people to do the code. I think we're just going to work smarter rather than harder, right? So I think the way, like, let's say 20 years from now, the way we code is going to be very different. We may not even sit down and code it out. It may all just be us typing in prompts, and then the prompts generate the code on the back end. I mean, even if you look at like how, like even the concept of Python, like I'm not compiling anything. A lot of people who are pure Python programmers don't understand compiling or don't understand anything under the hood. And they can do their jobs just fine. I think it's just going to be, our jobs are going to change, but they're not going to go away. We still got to do science. So, Chris.
Use a canned package. If you were doing something scientific, you would write that subroutine yourself because you had to understand, even if you're doing like Simpson's trapezoidal rule, you wouldn't use a canned package. You would write your own subroutine because there's a mistrust of anything that you didn't understand. We've come a long way since then, right? We now use canned packages and we don't even think about testing them anymore. And compilers and packages now are relatively robust, whereas in the past they weren't. I remember when languages used to give improper answers for a function like square root when you got like a new compiler. So I think the future sort of looks like that. Right now you might mistrust it because you're used to checking people's work, but when this has sort of the authority, then people might be more inclined to use ChatGPT instead of a postdoc. And yes, those postdocs now will have to step up their game.
I totally agree. Yeah, how about we can let folks in the room go and then yeah, so okay, so let's conclude here. I'll stick around and answer any more questions that people have, but thank you all so much. It's a really good conversation too.
Really quick before everyone's gone, we have another in-person seminar, not next Monday, but next Monday is Labor Day, but the Monday after that. That's Norm Grody talking about microwave radiometers, homemade microwave radiometers. Very cool. So thanks, everybody.